So in today's session, guys, this is another very basic and foundational kind of session we're going to be having. Okay, not much on reactive, but I'm going to be talking about a design pattern. Technically, you just need to know what is what, why we need this design pattern. But you know what? Is anyhow we are talking about all this thing. I just want to implement the design pattern by my own as well. And it'll be very straightforward. It's a very famous design pattern. You guys all know about it. This is called iterator design pattern. So we're going to be implementing it very simple and straightforward. But in the last session, we have discussed about the observer design pattern. And now we are talking about the iterator design pattern. Am I choosing all this design pattern like in a random way? No, this is not some kind of random design patterns. These are very special patterns. It's all prerequisite. We are setting off the environment and we're setting off our knowledge and foundation. And I hope we are on the right track. Okay. So let's just get started with this design pattern. Very famous, very popular, the iterator design pattern. Okay. Just 1 minute, guys. Okay. All right. So the iterator design pattern, So let's just go ahead. First of all, let me create a class. Okay. And before I create a class, I'm going to ask you a question. That why do we need the iterator design pattern? What is the advantages that we get when we use the iterator or iterator, whatever you are saying this? What is the advantages we get when you basically use a iterator pattern in whatever programming language that you guys are using? But this is Java batch. I'm sure that all the people like are Java developers only over here. So why do you need iterator in Java? Yeah. Any thoughts on this?
Looping, Abhilash.
Correct. Looping. Spot on. But we can also do looping in some other way, right? So looping, so you're looping what? Okay, let's just discuss in this way. You are looping what, Vijay? Collections, right? So you're looping collections. So do you think iterator, you can apply an iterator to any kind of collection like array, list, set, map is, okay, array, list, set, vector, all these collections, can you apply an iterator and can loop through it? Do you think is correct or wrong? Understood my question?
Yes, Abhilash.
So can we apply iterator to any kind of collection and can iterate through it? Do you think this is a correct? Yeah.
Yes, we can apply.
It is in like I think it is in collections interface, Abhilash, like iterator is there. It feels like so all the collections which extends collection interface.
Yes.
Will be able to iterate, not the hash map kind of thing. Those are not extended from collection, right?
Spot on. Yeah, thank you so much. Thank you so much for this answer. Yes, absolutely. We have the iterator in our collection interface, isn't it? If we go to any Java API. So the collection extends to iterable. Okay, iterable means the iterable, I think this is having the iterator as a property. So if you want to have any kind of for each loop, you can just extend or implement to this. Okay, that's a different thing. Okay, we won't go into that. But now the thing is like here, we will be finding a method called iterator right here inside the collection interface. So anything which implements collection, they will be having this iterator functionality. Okay, but what is the advantages that we get out of this iterator? Anyone? What is the exact advantages? Yes.
We can check for the condition and like we can do ascending and descending sorting, Abhilash.
Correct. So we can check for conditions. So basically you are going to ask data, to a data source, and you're going to keep on asking data that do you have next element? Do you have next element? If yes, the data source will sequentially will be keep on giving you data. You're going to be asking for data. The data source will be giving you data. That is also correct. Okay. But still, I haven't got my answer. You guys are giving me all the correct answers only. Yes.
And also we can like kind of deletion and
Yes, that's correct. You can navigate through the data structure that the data source is using in order to store the data, and you're going to keep on getting data. You can also modify data, and modification is a separate thing. And you guys are spot on. That also I understand. But what is the main advantage of using iterator?
And sometimes you'll getting concurrent modification exception kind of thing, like if you are not actually
that is also I understand. So at the same time you're iterating, if any other threads is adding any elements to the collection that you're iterating, you're going to be getting concurrent modification exception. That also is a correct statement. But what is the advantages of using an iterator? You are into that path. Okay. Yeah.
It just simplifies the code. Like
Ah.
easy to read and
Basically, we can iterate over any collection without the type of the collection. For example,
Spot on. Both of your answers are correct, and that is something that I wanted to hear, Sagar and Prajakta. Right? Simplifying code, you don't have to understand what you're iterating through. You just need to ask for the next element. You're gonna be getting the next element. You're gonna be keep iterating. And what Sagar said, you don't have to bother like what collection you're iterating, isn't it? So basically, it's pretty simple. Like in Java way. Why I'm not able to zoom it? Okay, let me close everything. Imagine you have a main method and you have a list, for an example, any kind of list, maybe an array list. Okay, the array list of string and a list equal to new array list of add all, and let's just take a collection and add all the elements. Let's say list of, and I'm going to say, let's say Sagar, let's say Swati, let's say Vijay, okay, let's say Prajakta. Okay, I'm taking some names over here. Okay, I have some names added to the list. Now this is an array list. Okay, I want to iterate the elements inside it. So I can say list.iterator, and this iterator or iterator, if I'm going to do command option V, is going to give me the iterator object. Okay, and this iterator, if you're going to go into this interface, it has couple of, mostly we're going to be talking about these two methods, the has next and the next. The has next will tell if you're going to be having any more elements in the list. The next will tell you if you have the next element, then what is that next element? The next element will get you the next element from the collection, right? So we got the iterator object over here. We created out of your list. We don't know what kind of data structure this array list is using behind the scene to store all the data that we're trying to insert inside the list. But we can apply the iterator. It's gonna get us a hold to the internal data structure that this array list is using in order to store all these elements. And we can keep on checking inside that internal data structure, must probably say array, which is backed by an array list, right? That array, we're going to be having hold to that, but we don't have to bother like what it is using behind the scene in order to store the data. We can just say iterator.next to get the next element, and we can just print it out. Okay, and while we'll be printing the next element, we're going to be checking if there is an actually elements available. So maybe we can take a while loop and we can say iterator.hasNext. And if we have a next element, print it over here. Normal Java programming. I'm sure that all of you should be aware about it. Okay, if I'm going to run this, so we should get all my data that I have over here. But the important thing, you don't know like what this array list is using internally in order to store its data. Well, we know array list is backed by an array behind the scene, but that's okay. But what about if it is a linked list, right? If it is a linked list, okay, and if it is a linked list, already Swati mentioned all your linked list, array list, they all have extended from the collection. The collection has the iterator. That means this will also have the iterator. And if it has the iterator, you can just apply the iterator over here. You're going to be having the iterator object, and you will be iterating through that, right? If I'm going to run this will work as well. Look at that. This is also work as well. Now the thing is, the way array list has been implemented, the linked list has not been implemented in that way, right? The linked list basically stores all this as objects, right? As node. It doesn't use like an array kind of a concept, right? So, but still, our iterator is working fine. What we are concerned about over here, we want to iterate through the elements that we have inside the list, okay? And that is getting exposed through this iterator. The iterator has access to the internal data structure the linked list is using in order to store the data, okay? I think this makes sense. Okay, one more example. It could be a set, right? The set and list are completely different thing. Here, this is unordered, right? Maybe we can have a hash set over here, right? And I can take hash set, okay, and hash set. Oh, we have a adult method in the hash set as well. And look at that. Let's just run this, whether it is working or not. Okay, look at that. It's working. Well, the order is not preserved. Swati comes first over here because this is an hash set, right? But the thing is, the iterator is working like a charm. It has the access to the internal data structure the hash set is using behind the scene, and using, like hash set behind the scene uses an hash map, and the hash map basically uses some kind of, internals. There is a certain internals like is there in, hash map, right? The way it works in Java. So I think you understand the uses of an iterator, right? You don't have to care about what kind of collections you are using, but the collection exposes an method called iterator, and anything with anything like set, list, vector, let's say array list, linked list, whatever, they all are implementing collection and exposing an implementation for this iterator object. One thing that you can see over here, I've applied this iterator over a hash set. Previously, I have applied the iterator over the linked list, and previously I have applied the iterator over an array list, but all the time I got an iterator object only. Okay, I haven't got the implementation object, I got the iterator object, right? But I'm sure, as Swati was saying over there, like, we have the collection, inside the collection we have the iterator, right? So if you go to any kind of collection like array list, for an example, where is array list? We have the array list over here. Then, the array list, if I'm going to do function command F12, and if I look for the iterator method over here inside that array list class that the Java people has implemented, you can see they're returning a new iterator object, and inside this iterator, this is an internal class, is the inner class. This implements iterator, and that iterator is the same interface which has a couple of methods. Now it has implemented the has next and next method and gives us the implementation. Like that, if you go to any kind of class like this, array list class, this is the array list class, right? If I'm going to come over here, this is an array list class. Like that, if you go to any kind of class, if you're going to go to linked list class, see, if I have a linked list class, over here, if I'm going to do function command F12, and if you're going to look for iterator, okay, it may be in the the class that is extending right now, maybe it will be over here or somewhere, but we will be getting that iterator. See, we have the iterator over here, okay, and it's return a list iterator object, okay. So the linked list has a special type of implementation called list iterator, okay, and this list iterator should have been a class which should be having those implementation the way it works, right? If you're going to go to list itr, it should have that has next method, a next method, and all those things. There should be some implementation behind the scene. So what I wanted to say, I don't want you to see this internal code, but what I wanted to say that every classes that we have, like array list, linked list, or blah, 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 they basically gives their own implementation to the iterator method, the way it will work behind the scene. Okay, I hope this thing makes sense. Can you just give me a clarity and confirmation that this thing makes sense? You actually understand why do we need the iterator? Guys, no questions on this, right?
Yes,
Yeah, I expect no. Now, that's the concept, guys. If you understand this, that's good. Iterator means we are keep on asking for the elements, and we are keep on getting elements whenever we are asking for it using the next method, right? I want you to just understand this much concept, okay? But actually today is Friday, and I cannot continue with something, and I don't want to break something in between. So what I want to do, in the meanwhile, I'll implement the iterator design pattern by myself, and that will also give you a solid foundation, like the way you will be using iterator and why we should use iterator and what is the pro and cons of that. So I can utilize that idea of yours whenever we will be talking about some other part of the course. Okay. So now let's just go to our iterator pattern. So first thing what we will do, imagine we have some kind of a class, okay, some kind of a repository class, maybe course repository, okay. Imagine this is a course repository class which is going to store some courses that I do teach, okay. So maybe I want to represent my entity. First of all, I'll go ahead and create a class called course, okay. And this course, imagine this has only one property for now, private string course name, okay, name of the course, and I have the getter and setter for the same, okay, and also I also have the constructor for the same to initialize the name property, and maybe I'm gonna also give a toString method. So sometime if I want to print the course object, I'll get the content, not the reference. So toString method, right? So I have this course object or course class, and I'll go to course repository. Now what I want to do, I want to give some methods over here. For an example, public void add course, okay. Let's say I want to add some courses, then I can utilize this method, and I can take a course object over here, okay, and I will be able to add the courses, right? So for an example, I'll go to my project, I'll go to my client application, I'll remove all this thing right now that I have coded, okay. And what I want to do, let's say I'll create the course repository is equal to new course repository, and the course repository dot add course, and let's say I'm gonna add some courses, let's say new course, and let's say Spring Boot, okay. And like that, I can add few courses using my add course method, let's say Java, okay, and let's say microservices. Let's say I have few courses right now, okay. Perfect. Now let's just give an implementation to this add course, the method that we have created. Well, we are adding a lot of courses. So whatever courses we are adding, maybe we'll try to use some kind of an internal data structure where I'll be keeping my courses, okay. So maybe I'm gonna use an array. So private, let's say course array I'm gonna create, okay, and let's say courses, and maybe I can initialize that array over here, new course. Maybe I'll initialize it to 10, just for now 10, and then every time somebody want to add a course, I'm gonna say courses, which is my array, and then I'm gonna add to its index like 0 and 1 and 2, and I'll be keep on adding the courses that somebody is going to put over here, okay. Like first I will add it to 0th index, then let's say Spring Boot is coming, I will add it to first index, then let's say Java is coming, I'll add it to second index, and I'll be keep on adding all my courses over here, okay. But how to make this possible? Maybe I'm gonna use a index variable, so private int index, okay. And if I do not initialize it, by default the integer default value will be 0, but just for your understanding, I'm just writing 0 over here, okay. Now every time I'm adding the course, I can use this first, the index 0, first the value will be 0, the course will go to the 0th bucket. Next time, whenever I'll add the course, I just want it to go to the first index. So I need to increase the counter every time I add a course. So I can just do index plus plus like this, okay, after I add the course, okay. And now all my courses that I'm adding over here right now, Spring Boot, Java, microservices, will be go into this array and will be stored like this, okay. And I hope you get it. Like, let's say first Java will come, it will go over here. Then let's say Spring Boot will come, it will go over here, okay. And let's say, it will go blah, 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 like after that. And then, we have right now 10 elements like this. So the rest of the elements are filled with null. Next time, you are adding a new course, it will go to this null, and this will be, let's say, microservices or something, right? So I think this is very simple. Anyone can understand this. And I think nothing fancy over here. So you have an array where we are storing all our courses. We're adding all our courses over here, okay? Which is good. Just to improve this code, whenever I'm adding the index over here, so I'm just saying index is 0, so courses of 0 will be the course that somebody is giving us. I'm trying to assign it over here, and after adding a course, I'm going to increasing the index to 1, so now this value will be 1. Next time, whenever somebody will call this and want to add a course, this will go to the 1th index, then it will be added, it will be increased to 2. So instead of doing this, I'll directly do this over here, post incrementation, something like this. So after this statement is executed, the index will be increased to 1, like increased by 1, okay, plus 1, okay. So instead of doing that, you can also do this, do like this, in one line, okay. This is just plus 1, okay. Cool. So right now, all my courses, I have it I already have it in the course repository, okay. So now, let's say somebody want to iterate through the value that we have inside the course repository, right? Now, somebody wants to iterate through the course repository, whatever the courses that we have over here. So where we are storing the courses over here, right? So the thing is, I do not want to give a direct access to this internal array object that I have over here, okay? So I do not want somebody to touch this, okay? Rather, I want to give a kind of iterator pattern so that somebody who is interested to iterate through the courses that I am storing inside this array, maybe they can access this internal collection, or the internal data structure or the internal array through the iterator object that I'll be exposing, okay? So no direct access to this. So how can I give them that feature? Let's just design the iterator over here. Okay, so let's just create the iterator interface. I'll go here and create an interface over here. I'll call it iterator. Okay, and this is my iterator interface. And this iterator will have a couple of methods, let's say. One will be hasNext. This will give you whether you have a next element in the list or in the collection. Okay. And the next one, if will be the next. This next method will give you if you have an object inside the collection that you are trying to iterating through. Okay, this next will give you the object. So we'll basically have this couple of methods for now. Okay, and now what I want to iterate through this course repository with this collection or with this array. What I want to do, I want to create a new iterator for this course repository. Okay, I'll name it course iterator. Okay, I told you I'll not give direct access to this. Rather, I'm creating a course iterator. So here, inside the course iterator, I will do what? I will implement the iterator, make sure it's coming from your package, not from the Java util. And because they have iterator as well, as I have told you, right? So I'll implement all the methods that I have in my iterator, interface. Now I'll give the implementation to hasNext and next. Okay, let's talk about next. What it'll do? It'll just give you the next element from the list, right? So the next element from the data structure that you're trying to iterating through. So what is the data structure that you are trying to iterating through? Is the course repository. Okay, this is the array that you are trying to iterate through. Now here in the next, you want to give the next element from the array that this course repository is using right over here. Okay, so how can you do that? You have no reference over here to the array that your course repository where it is storing all the data over here. Now what you want to do, the next method over here need to have access to that array so that it can give you the next element from that array where we are storing the data. So how can you achieve that? The question makes sense or the question doesn't make sense, guys? The next method implementation. What do you think?
Yeah.
Yeah, Swati. How can you implement it?
Yeah, generally, like in the collections, like it seems like they have given in inner classes. Right?
Correct. We'll come back to that. So if you're gonna use the inner class, that will be pretty much a easy implementation, and that is something that I do recommend. But right now, let's keep it simple. So right now we don't. So what Swati is saying that okay, you can go ahead and create an inner class over here. Okay, you want to have reference to this, internal data structure where everything is get stored, right? So what Swati is saying, go ahead and have your class, let's say private, let's say class, and thank you so much, Swati, for noticing that whenever I open that array list implementation. And obviously if you go to any kind of implementation, the way Java has implemented the iterator pattern is just like this. They have a inner class, like let's say course iterate, let's say iterator, let's say iterator new or something. Let's say a new iterator. I'm writing a double R over here. Let's say implements iterator, and this is your iterator. Okay, if I'm gonna do this, this is your iterator, and now you can create an inner class like this. Now let's say if you're gonna implement the methods over here only, now you can see you have the course iterator over here, right? Now you have the next method over here. Now you want to iterate through what? Through this collection. Now, as you are creating that class over here inside this course repository, you have direct access to that array, right? You can just use that array like this. Courses is your array. Then you can take an index and let's say 0 or 1 or 2. Then you can keep on getting the element from this courses array, right? Because you have direct access to that array. For an example, maybe here inside my inner class, I can create another variable, let's say private, let's say int position, and I'll initialize it to 0, and I can just do position over here. And every time I'm gonna do a next, I'm gonna increase the position to position plus. But I cannot do this after the return. So as I said, after you complete this, you can just do position plus. Now this is gonna get you the next element from the array, right? So what I told you, like you need to expose this create iterator object, right? So that you need to give a factory kind of method. So you can give a factory method like this. Let's say get iterator or create iterator, or just like iterator, just the collection framework is giving. So you need to create a method like create iterator, and make sure this create iterator returns this object, right? Course iterator object. Okay, so like this, and the create iterator will return an iterator object like this. Okay, this is our interface, and for this interface, okay, we have an implementation which is this course iterator, okay, that we have created as the inner class over here. Okay, now whenever you want to have access to this courses array, so what you can do, you can go to your app class, and the course repository right now have an a method called create iterator, and this will give you an iterator object like this. Okay, this is your iterator object, and now you have access to the course iterator, because this create iterator method internally returns this course iterator, and this is a private class. Nobody will have direct access to this. Okay, nobody will have direct access to this, and nobody will have direct access to your original collection where you are basically storing the data. Now they will have access to this, and this class internally will iterate through this collection. Okay, like this. Okay, so now if I'm going to go to the app.java, and I have created the iterator, and I can say iterator, and I have a next method. And if I'm going to do this, and I'm going to do s out, the next method will return an object, and I'm going to print that object. Okay, something like this. Okay, now if I'm going to run this, should I get the next element? Let's just see. Okay, see, I have Spring Boot over here. Okay, now I want to get the next element again. So again, I will be asking for next. Again, I'll be asking for next, right? So if I'm going to run this, I'll be getting, okay, Spring Boot, Java, microservices, right? Can I do next again? Absolutely you can, right? There are 10 elements. You can do next, 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 next. Okay, if you're going to do next, 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 now you're going to be getting null, 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 right? Because we have only 3 courses over here. If you're going to have one more course, okay, and let's say this is Docker, if I'm going to run this, you're going to be getting Docker over here, but the other 3 things are null. Okay, so what you have to do, you have to only return a next element. You have to check whether you have a next element. If you have a next element, then you return it. If you don't have a next element, don't return it, right? So maybe what you can do over here, okay, how to find if you have a next element or not. Okay, so now your next is working fine. The next is giving you the element, but how to find whether the next element is there or not? Maybe I can use a while loop. As I said, I'll just run a while loop, and I'll check if the iterator has the next element, right? If it has the next element, then I'll run this. Okay, I'll tell, okay, get me the next element, right? So if I'm going to run this, will it work? No, it will not work, because the has next implementation I have not given. Even I'm not getting even one item over here, because the has next is returning. If I'm going to go to the implementation, now this is the implementation that we are giving. So you can see now I have 2 implementation. If I'm going to go to the iterator, it's just saying 2 implementation, because if I'm going to go to the has next, one is course iterator. This is inside the course repository, the inner class that I have created, and there is another implementation I have created. Actually, Swati told me to create a inner class instead of creating a new class over like this. So I am not using this class right now. It can remove this. We will come into this. So like this, I will remove this. Okay, let the class be over here. We'll use this later. Now I'll close this class. I'll go to my iterator. Now there will be only one implementation. Okay, if I'll go to the has next implementation, look where we are inside the inner class, inside our course repository where we are storing all our courses. Now, if you go to the course iterator, we have given the implementation for the next element. Now we have to give the implementation for the has next element. But it's always return false. As it always return false, now when we are doing while iterator.hasNext, it is just giving you false in the first shot only, and you are not able to fetch the data. When app, being the consumer, is asking for the data, right, to the iterator being the data source is not able to give the data, because the hasNext is saying there is no more element in the collection. So let's just do one thing. Let's just go to the implementation of hasNext, and let's just do some implementation over here. So how can we be sure that we have elements present inside the internal collection? Abhi, position, correct, exactly. So I have to do what in the chat. Okay, 1 second, guys. Avi, who is this? Can I know your name, please? Avi?
Yeah, hi Abhilash, this is Abhishek.
Abhishek, okay. Can I know your short name, Abhishek?
My short name, you can call me.
Short name, I'm asking. Title.
Abhishek Jadon.
Oh, okay, Abhishek. And Abhishek, I also need to have a call with you. I told you, sorry, just got stuck with my work. But this weekend, I'll surely ping you, Abhishek. Sorry about it. Yeah.
No issues.
Yeah, okay, yeah. Sorry, Abhishek, to ask you that question because there are so many Abhishek from different groups. So,
Yes,
yeah,
no
okay.
problem.
It's a very common name. Even my name is Abhi,
Yeah.
so very common name.
Yeah.
Okay. So now has next, right? Has next, how can we give that implementation? As Abhishek was saying, okay, so we can check our position. So every time we are doing a next, we're incrementing our position, right? Position 2, 1, then 2 or 3 or 4. So how long we can go, how much we can traverse through this array, as long as we are in the end of the array index, right? What is the length of our array right now? What is the length of our array? It is 10. Okay, so every time I'm going to do a next over here, I'm incrementing this position, right? Now the position will become 1 in the next time, then will be 2 in the next call. Again, whenever we'll call next, it will be 3, like that, 4, 5, 6, 7, 8, 9, 10. And after that, if you're going to do again, then you'll get array index out of bound exception or something like that, right? So what we will do here, we will say if, right, if the position that we are maintaining over here, if it is less than courses, which is my array dot length, then keep on traversing, right? I'm going to say return true, okay, or else just return false, right? So as long as it is, I think array indexes starts from 0, so it will go till 9, okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, it will be 10 elements, okay, so 9, at last it will be 9 less than 10, true, then 10 less than 10, it will be false, right? So 0 to 9, it can go, it will be 10 elements. So if I'll go to app.java, right now, let's just try to run this. Okay, is that iterator working? Boom, it's working really good, right? But we don't have to traverse the null elements. Let's say I have an array which is a very big array which has around 1,000 elements. Then I don't have 1,000 elements, I have only 3 elements. Then I don't have to traverse through the entire array just because the array is initialized and we have the value inside it. This is just a data structure we are using to keep our objects right over there, right? So what we can do, we don't want to get this null. Okay, so we will add one more condition. The has next will only return true when we have the next element available inside our array. So if I'll go to the has next, I'm going to use another condition, make sure the position is less than the length. And in my course array, if you're going to look for that position, that should not be null. That should not be null. That's not equal to null, right? Now, if I'll go to app.java and run this, this should work like a charm. Look at that. Okay. Now your iterator is in action. Now you have successfully created an iterator pattern by yourself, right? Just like this. Okay. This much of code makes sense to you guys? Look at this. We have the course repository. Okay. Here we have a collection where we are storing the data, right? And then we are creating an iterator for this. Our iterator has a couple of methods. Has next to give you the next element. Next to give you, has next to check whether there is an element available inside an array. And next, if you want to get the next element, you can call this next method, right? And for the simplicity, you have kept all your needed method that you need to give inside the iterator, like has next and next, which are very common operations. But as Vijay and Swati, they were mentioning, if you want to add more methods over here for traversing backward, also you can give that extra features over here as well. Okay, but this thing makes sense, whatever we have done here. This is one way of doing things. Okay, you might see your fellow developers will implement this thing in a different way, but this is one of the easiest way. Okay, actually I wanted to implement it in another way around, but the question Swati asked me, this basically hit me hard because this is the right way. I feel like this is the most convenient way to do the things. Yeah. What is the advantages? Yeah, ask me the question.
Actually, what is the advantage over that iterator which is there in the collection? What is the advantage? We can use that iterator only, na? Like,
we can use that iterator. Okay, what is the advantages of creating your own iterator pattern over here. That's what you are saying.
Yes.
Vijay, have you heard an interview question anytime like reverse a string without using the string reverse method?
No, Abhilash.
No? It's a very common interview question. Reverse a string without using the strings reverse method. How can we implement in the other way? Just curious. Yeah, Dinesh, I'm telling you that. So basically, Vijay, you can basically use the Java iterator method. This is a design pattern. We are talking about the design pattern, the way you can implement it, your own iterator. Okay. The thing that I want to show you over here, being the app being a consumer is asking for data. Okay. The iterator is helping you to process a sequential data stream. Think normally. Okay, we'll come to this design pattern. We'll come back and we'll talk more. Okay, but okay, let's just have the technical aspect of it. And Dinesh, I'll be also coming back to your question. Just give me a minute. And Dinesh, also we need to have a call. I think we have a call scheduled right on Saturday. So I'll be meeting you. I'll make sure to meet you. Sorry, I just missed your chat last time.
Yeah, thanks, Abhilash.
Oh yeah. So imagine we have what we are doing in the iterator pattern, guys. Just see this diagram. We have a consumer. Imagine this is your app, and you have a source which is basically emitting you the data. The consumer is asking for the data, right? Imagine this is your consumer. Okay, look at this diagram. This will help you a lot while understanding reactive. Okay. End of the day, you just need to know how it works. That's it. And the methods and everything, anybody can call and can use it. See, the consumer is gonna ask for the data. It's gonna do you think this is an iterator pattern? Imagine this is a consumer. This is a source. The source has the data. The consumer is asking for the data to the source. So do you think the iterator works in a pull-based model or a push-based model? Is source is pushing the data to the iterator, or iterator is asking the data to the source?
It's pull kind of thing.
Is it not pull kind of? It's pull. It's pull.
Yes.
Right. Question. Yeah. Pull. Correct, Abhishek. So it's a pull-based model. So basically, the consumer is asking the source, okay, just get me the next element. Okay. Yes.
Like pull and push, I didn't quite understand.
Because you haven't seen the last video, Prajakta. Push means the source has the data. Imagine, Prajakta, how can I tell you? Okay, imagine the source has the data. Okay, now source has that collection which has all the courses. Now the source is giving the data to the consumer that, okay, I'm pushing the data. Like, okay, now I have one data called Spring Boot. I have one data called Java. I have one data called microservices. I have one data called Docker. Source is pushing the data like this from here to here, the arrow in a backward direction, something like this. That is a push model, right? The source is updating the data to the consumer. But here, the consumer is asking the data to the source, isn't it? Look at your code. You are creating an iterator, and app is what? App is a consumer, which is consuming the data over here. Isn't it, Prajakta? So you are consuming by writing iterator.next, you are asking the next available data to the iterator. And the iterator is going behind and talking to your repository, which is the source of your data. Okay. The repository has the source. Repository is the data source, which has the data. You are asking the data. The app is asking the data to the course repository in a way, isn't it, Prajakta? So that's why when you say next, the source is giving you the next value like this, right? The source.
So it is pull kind, right?
Yes, it's pull kind. So basically, who made the request? Consumer makes the request to the source, and you get the data, you get the value. The source has given the value, but it will only give you one value. the consumer need to take that value and need to process that first before asking for the next value, isn't it? So again, the consumer need to ask for the next, right? Just important this diagram. This will help you, right? The consumer will ask for the next again, right? And then the source will give you the value again, right? So every time the consumer need to make a request to the source in order to get the value from the source, okay? So two things you have to understand. It's a pull-based model because the consumer is pulling the data from the source. Second thing, the source need to send only the value that the consumer is asking, okay? And the source is emitting the value in a sequential way. You understand the sequential way? One after another. The source has 10 value. Let's say Spring Boot, microservices. It will give you value one after another, right? The way you have stored it. Sequentially, it is giving you value. First, for whatever value you have stored first, that is also coming here, emitted by the source, going to the consumer. Okay, it's working like this. Okay, now coming back. Okay, coming back to this. So this is how this iterator design pattern working. We can also modify this. I'm going to give you a little bit of assignment if you want to try that in your at your home this weekend, but just hanging around. We still have 10 minutes. So this is one way of doing things. Okay, did I forget anything? I think I was trying to explain something, but I forgot. But yeah, let's just come back to question asked by Dinesh. So let's say in the course repository, now the way I have implemented my iterator pattern by implementing an inner class over here, right? Let's say I will not use this inner class like this. Okay, I'll not use the inner class like this. All right. So yeah, all my code compiles fine. Okay, that's good. Now I don't have an inner class. Now what I want to do, the course repository has my array which basically stores all the elements. So what I want to do, I want to create a separate class called course repository. Oh, sorry, the course iterator. Okay. And here I want to implement my iterator logic right now. Not as an inner class, by the way, but it's a separate class right now. You will see implementation like this maybe in your project if there is a need. Vijay, like you might have need like to implement your own iterator pattern if you want to have control over the internal data structure and the way you will be emitting the data. Okay. So in that case, if you're going to use this, okay. So you want to create your own iterator. So it needs to implement iterator. And now the thing is the next need to traverse the original array where you are storing the elements. And, it need to paste the data from the original array and need to give you the next element. So how do you think you need to implement it if you want to go in this way? Any thoughts on this? Question makes sense? Because I don't have any array over here. How can I traverse through it? My question makes sense?
Yeah, maybe Vilash, we can
Yes,
pass
Vasu.
that object, course array into this course iterator object. Constructor.
Absolutely perfect. That's the thing that I want to hear. So we pass through the constructor venue. Yeah, thank you so much. So basically what Vasu and Venu has mentioned that, okay, you don't have the object over here, but grab that object, right? So what you can do, so you can have a course object over here, course array over here. So course array, courses, and I don't want to initialize the course object over here. Okay. Who will initialize the course? Okay. I'm going to make it a private array object. I don't have this array. This is just an empty array. I want to initialize this array. Okay. How can I initialize this array? Through a constructor. Maybe I can create a constructor like this. Isn't it? If I'm going to create a constructor like this array will be initialized. Where this constructor will be called? Well, I told you in your course repository, okay, you have a kind of factory method which is going to create an iterator for you. Okay. And whenever you're creating a new iterator, so this is your course iterator, you need to give something in the constructor. And here in the course repository, you have access to the original array. So put that array over here. Okay. Now the create iterator, when you will be invoking, okay, of the course repository, the create iterator internally create your iterator object. Okay, what kind of iterator you are creating, don't expose it to the client, because you might have seen, like in your array, you have seen some kind of a iterator in your array list, what we call ITR, list iterator, some kind of implementation. Are you using those things directly? No. Like that, we have created our own iterator called course iterator. That will be our internal implementation. Okay, but when somebody will call this method, they will get a normal interface object over here. Okay, so don't return the course iterator object directly over here. Now if you're going to go over here, this is your constructor which will be called, and you are getting your array. Okay, you are getting an array from there. Okay, this is the array that you have where you have the data, sending those data and going to the constructor, you're receiving the data, setting it with this. Now whatever data that you have over there, I've deleted it. Okay, the same data you'll get over here. Okay, all this array filled with data, you'll get everything over here like this. Okay, everything will be filled, blah 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 blah. Okay, so you have access to the array right now inside your course iterator, and you know how to do next thing, right? The next method you can implement, you can return, you can have another variable over here called private int index. Okay, index, something like this. By default, the int value will be 0. Okay, now you can take this index and can iterate through this array, right? Return your array and you go with the index like this, and just do plus plus once you fetch the data. And for the has next, you give the implementation, right? Okay, let it be false, and you can say if, okay, same implementation, if the index is less than courses dot length, or sorry, and course array index should not be null, then only you'll do the has next. I have already told you how it works. You can just practice that. Okay, in this case only you'll be returning true. Okay, so that's it. That's your has next implementation. That's your next implementation. This is your course iterator. And now what you're going to do, you go to your app Java, nothing has been changed. You just instead of an internal class, you just created a other class for iterator right now. Okay, so now whenever you'll be calling the course create iterator, you're going to be getting the iterator over here from the course repository. And then, okay, once you get the iterator object, you can ask for the next and print the next element if it is available. Let's just run this. This is the answer to your question, Dinesh, and you get all your values over here. Okay, so this is another way of achieving the iterator thing. Okay, we'll talk about the pitfalls of it, but everything makes sense, whatever we have discussed so far. Any questions? Any specific questions? Thanks. Oh, no problem, Dinesh. Any specific questions? In the chat, we can still end up having array index out of bound exception. Okay, in which scenario do you think you will get array index out of bound exception, Arbaz?
If we keep on calling the next function without checking the has next, right?
Exactly. So here what I did, you are correct. So okay, now in this case, do you think the array index out of bound exception will come in this scenario?
No, not in this.
It will not come, right? If you're going to directly call next, you might be ended up having that issue that you are saying, right? That's what you are saying. Let's say I'm gonna
in regular also we are getting the same, right? In normal iterator also, like in collection list.
But the normal array list thing is a dynamic array. It grows, right? But yeah, that's a valid question. Okay, why I want to answer this for a different reason. Okay, you are getting out of bound exception because we like after the 10th element, if you're trying to access the 11th element, obviously there will be a problem in this implementation, and you are correct, right? So basically, you need to have a kind of way to stop, having the next element if you don't have any elements, right? So maybe you can have a if else clause inside your course iterator. Okay, so you can just check if the index is between this, then returns this, otherwise just return a null element. Or but just for now, just to be in the safer side, in the return statement just write a if else clause. If the index is less than this, okay, then return this, else return null. Okay, just to avoid that exception or buzz. And one more thing Swati has raised, one more problem Swati has raised. Swati has a question about this, like not a question. I think he was mentioning about this, like concurrent modification exception. There's something which is not a good thing in iterator patterns. Imagine, we'll consider this pitfall later because we don't need to get into that thing much, but just want to mention over here that in app.java, let's say you are iterating. Okay, you are iterating through different elements that you have over here. Okay, now while iterating, you do not want some other guy, once the iterator has been created, some other guy is going and actually clearing, you are creating the iterator out of this array, clearing all the elements from the array. Or some other guy is going and adding one more elements to the array while the iterator is in progress. Okay, so concurrently, if while you are doing it iterating over here, concurrently mean in the same time, whenever you're doing the iterating, if somebody is trying to change something, the original collection, okay, you should not allow that. That's why you can throw a concurrent modification exception from your end, or just don't allow that, right? Because if somebody adds a new element over here into the iterator internal data structure to this array, then what will happen? You'll get inconsistent result. You might have 10 elements in the array because while iterating, somebody has added an element to this array, but you are keep on iterating. Okay, so that is one more thing that you have to consider that. But yeah, let's just forget about all this thing. I think we understand why do we need the iterator pattern. I just want to show you this diagram. Okay, that's it. If you understand this diagram, you don't have to do anything else. If you don't understand how to code it, that's also fine. But yeah, as we have done all this thing, maybe better I can use this video as in my design pattern course. So what I can do, I also want to draw the UML. So I want you to do the UML for me. So okay. Before I do the UML, guys, in your regular practice, right? What they suggest you. So you forget everything right now. Come back to our iterator pattern. I'll close everything. Okay. So I have a course. This is my domain object kind of a thing. This is my pojo. I have a course iterator, which is helping me to iterate through all my courses that I'm storing inside my course collection. And the course repository is used as a course collection for me, which is basically holding the data over here. Okay. And most importantly, my course repository, which contains my course data like a collection, exposes a create iterator method. That's the most important thing. So you might find whenever you are learning the iterator pattern, or if in your office also, if you're gonna seeing any UML diagram, most probably they will create a new interface. Okay, just like you remember, you have collection and list. The collection has the iterator method, which is abstract because collection is an interface, and the array list overrides that collection's iterator and gives it an implementation. Okay, same like that for your course repository. This is your main method, right? This is the method that you are most concerned about. So anybody who wants to give an iterator feature, for them, you can create a super interface or super interface, something like, you can call it a container, okay? Or you can call it maybe I'm gonna say it collection. It'll make more sense to you, okay? I'm gonna say collection. This is not Java collection. I'm just creating an interface called collection. Make sure you need to define this abstract method inside this super interface, something like this, okay? And the class where you are basically exposing your factory method, which basically helps you to create an iterator, make sure you implement collection like this. Okay, this is my own interface called collection, which has this create iterator method, and I'm just overriding this over here, make it public. The default keyword by default is causing a problem because the interface methods are by default public. You have to have the same signature while you are doing a override. Okay, so make sure this is something that you do. Okay, so let's just try to right now make this UML, and we'll just wrap up our session for today. We'll meet next on Wednesday. If you have Office, please drop off. I'm not going to do much of work right now. I'll just draw the UML. Okay, and I think you guys can do it by yourself. So the first thing that we have over here, we have created this class called collection, right, which has this create iterator method. So I have an interface called collection. It has one method called create iterator, and this is a public method, right? I have the create iterator method, and what it gives a iterator object, right? Something like this. All right. That's it. So the next thing that I want, I have another class which implements this class, right? So I can do this. This is an interface. This is a class. Which class is this? The implementation for this is course repository. Okay, that implements collection. So take this course repository, course repository. Okay, inside this course repository class, the main thing that you're going to be having, any design pattern, any iterator design pattern that you're going to be using, the main thing will be the array. Okay, this can be implemented through an array or binary tree if you want. If you want to search for an element, binary tree also can be considerable. But here I have used the array-based approach. So here I have a course array, right? I have a course array variable, and this is a course type. Okay, the course array is the variable name, and this is the type is course. You can see course array over here. The variable name is courses, and the type is course. Okay, so maybe I'm gonna say courses array, and the type is course. This is the main thing. You can put a line over here. These are the variables, and the main method that we have over here is this. Okay, we have a public method, so you can make a plus over here for public, and we have this method, and also we have another method called add over here as well inside our course repository. So I can put another plus and add method, and this says void, so you don't need to write void, but you can also write void over here. Okay, so these are my major methods that I have inside my course repository. Now the next thing that I have is the iterator pattern that I'm using, right? So I have a main interface here called iterator. Okay, in my iterator there will be two methods. One is has next. This gives you boolean. Another next. Okay, the next gives you an object, right? Something like this. Okay, and then we have an implementation class, and this class what we called a course iterator. Okay, so this basically overrides the has next and overrides the next. Okay, so all these are public methods. Okay, and that's why I'm giving all these things to here. Okay, and if you want to specify that array that you are using, you can also create an array like this over here. Okay, this is the course iterator. So the course iterator basically it's having an easier relationship, like this implements this. So maybe I can have an arrow over here. So this implements this, right? There you go. This implement course iterator implements this. Okay, so you can also write implements over here, and then you can also see we have course repository, right? The course repository has a constructor, isn't it? You can see in our course repository we don't have a constructor. We have a method like this, okay, called create iterator. This create iterator internally using the course iterator constructor and creating the object of course iterator. So this course iterator object, this course repository creating. So the course repository using the course iterator behind the scene. Because you can see again, it has some kind of a method call or a constructor call where it is using the course iterator object over here. So I can say it has a relationship, the course repository has a relationship. It has a relationship. I'll change this to this diagram because, sorry, maybe something like this. This is better. So this uses course iterator like this. And one more thing we can say, the course repository also implements from this. So I can use this symbol for implements. This implements this, and we have iterator pattern. This is my iterator, and my course repository is here. Okay, that's good. So your client will directly utilize the course repository, create iterator method over here. Okay, we also have a domain class called course. You can also create a domain class, and you can put this symbol, has a symbol over there, because we are also using inside the course repository. We are also using the course class over here, right? It's a course array, right? So we are also taking courses over here. Okay, add course is taking a course inside it. That's what I'm seeing, like, where I'm using this. So you can see add course is taking a course object inside it. So if you have anything inside the parameter, that means we also have has a relationship. This course repository also, maybe I cannot draw this diagram, over here. So I can have one more class like this. So it has a relationship. So I can have this kind of an arrow because one of his method uses the course. So I can create another class called course. Okay. And you can just specify all this variable that you have. Like for now, I think we have only one variable there called course name, which is a string type. Okay. So there you go. Course name of string. And then you have some public setter and getter. So I can just, if you want to mention that, you can write get course name. Okay. And it returns a string. Okay. How small it will be. But I think you understand, right? And you also have a set course name, which doesn't take anything. Okay. Set course name. And in the parameter, it also takes the string, right? Maybe you can just write string over here, and that will make sense, right? So I don't have any space, so I'm not writing. Mark this guys as plus and mark this guy as minus. This is a private variable. These are all plus variable. Put a has a relationship symbol over here because one of the method of the course repository uses the course object. Okay, because it is inside the method parameter. Okay, so something this kind of a relationship you're going to be having if you're going to look for any iterator pattern. Iterator UML. Should I open this because it's going to go to internet? Maybe I don't want to get copyright or something, but yeah, I think somewhat it'll be something like this. Look at this diagram. I'll blur this anyhow. So look at this. We have an aggregate. Aggregate means the main object. For you think like you have a collection or the main factory method that you have created over here. Okay, like this. You have this collection. Some people call it aggregate. Some people call it container. And you have this factory method over here. And that's what they're saying. Then you have a concrete aggregate. For you, it's a course repository, where you override that method, right? And then you have the iterator, the concrete iterator over here. Okay, that's it. And there's the relationship. The concrete iterator uses this concrete aggregate, uses this concrete iterator. Okay, maybe whatever diagram you're going to see, right? I think this will make sense to you. Okay, you're going to be getting pretty similar diagrams, so nothing to worry about it. This is your Java collection iterator pattern. You have collection, you have iterator, then you have list, which basically extends to collection. And then your client will directly use the list iterator method, but the list iterator method internally has a list iterator, right? List uses list iterator as an implementation, and list iterator super class is implements from the normal iterator interface, which has next and next. Okay, you're going to be getting similar diagram all over internet. I think whenever you're going to be looking into this, things will pretty much make sense to you guys. So nothing to worry about it. So that's it for today's session then. Okay, sorry. That's it for yeah. Yeah.
Abhilash, here the highlighting point is like we are hiding the actual source. Right?
Exactly. We're hiding the actual source, and it's a pool-based model.
It's a pull-based. That
Just
is the entire thing.
Entire thing. Okay. All my class 1 hour, just understand it's a pull-based model. That's it. Okay.
Yes.
And why do I want to show you the implementation? Because I want to relate things. I don't want to talk things जो बोलते हैं ना हवा में बात करना, वो हवा में बात करेंगे ना तो समझ में नहीं आएगा. तो I don't want to speak like something which you guys cannot relate to. I assume that everybody who will be watching this, I do not care about your experience. I want to feel like I'm learning for the first time, and whenever I will be learning reactive, I need to make myself understand. Okay, let's just go in that way, and I think we'll need 2-3 more classes to get our foundation ready, then 2-3 more classes to get our reactive foundation ready. And again, I'll tell you, this reactive is kind of a learning curve we're going to be having. Like you learn Java, you haven't learned Java in one day, right? You know, like how much hard work that you have put to learn Java. It's huge. Like that, reactive is a new way of coding things, okay? Because problem and solution, why we're using reactive, I'll be telling you that. But it's a new way of coding things. So it's a new way of seeing things, which is booming right now. Maybe after a while, you're going to be using reactive all the way, right? Maybe if you are in a very big enterprise application, you are developing microservices. The microservices also will be in reactive manner only. It'll be, creating. And Spring has absolute great support to that. So to have that foundation, these things are required. Learn it and then forget it. You don't need to understand everything, mug up everything. So just learn it, forget it, and then end of the day, there are 5, 6, 7 things we'll be using all the time. And that's what I all want from you. The gist. This is what is, and this is how I'll be using it. Okay?
Yeah, here Abhilash, we have in the React JS also it is there, it is from the front end point of view, right?
Yes. If you're gonna link the design pattern, the way I haven't spoken anything about the reactive programming, but in the next session I might going to relate few things like how the iterator pattern works, how the observer works. Then reactive has introduced a way back, I think a reactive X or something. It used to be before, right? Java also has an API. If you're gonna come over here and if you're gonna do a shift, and if you're gonna go to classes, if you're gonna do the shift, if you're gonna look for publisher, okay. If I go to classes, concurrent, see this publisher, this is an API present in this package. So Java already has an API created for reactive programming, okay? And then there are a lot of implementation, like Project Reactor is one of them. This is what that we have used last time, right? Maybe a little bit of coding example that I've shown you, but I haven't spoken anything. So Project Reactor, you'll be hearing that name a lot because that's a very good API for this specification. Like you have JPA and Hibernate, like that. For this reactive API of Java, there are a lot of implementation. You might be hearing about the Akka stream, okay? You might be hearing about RX Java. You might be hearing about Project Reactor. Project Reactor is a very good API. We'll be learning that. Why? Because I have my benefits. First thing, the benefit is the Spring. The Spring internally uses Project Reactor only. So I don't see a reason to jump into the RX Java or something else, because this is Spring is something that you guys care for the most. And for that only you are taking the course, right? So that's something that we'll be discussing. But yeah, you put the reactive part, the DV also have support. The Mongo also have support. The front end part also has support for the reactive. The way reactive is just a concept. How different people are implementing different things. How JavaScript has implemented it. How .NET has implemented it. How Java has implemented it. And there are a lot of library. Okay, this is the reactive concept. JVM has some specification, Java has some specification. There is some guy called Project Reactor. They are giving some API to you, right? And the first rule of reactive programming, do not create your own things. Like I have shown you a implementation like publisher, right? Don't create your own publisher. You can do, the specification is very simple. I have shown you that publisher, right? Look how simple is that. It has only one method. You're like, okay, this has only one method, right? So yes, I can create my own publisher. Why do I need to create? Why do I need to have my need to add an API over here like Project Reactor? The first rule of that, first rule of reactive programming is that coming from the creators only. Don't create your own publisher, and see how many implementations you have for this publisher. 332 implementation. So when you're going to be adding one more thing, the Reactor API, I think we're coding in this package. This is the Project Reactor dependency that we have added. This is a support for the this reactive API that the Java is giving you. In the last session, maybe in one of the session, I was talking about a publisher called Flux. If you're gonna go on internal and look at the internal thing, that will be implementing this interface only. So we'll be talking about all this thing. So there are a lot of things. In the next session will be on Wednesday, guys. That's it. Thank you very much, guys. Have a good day and bye-bye. Have a happy weekend. Bye-bye.
Thank you, Abhilash.
Thank you. Thank you, guys. Bye.
Thank you, Abhilash.
Thank you, Prajakta.